today we'll be starting with the session 3 of Android Study Jams. So in the previous sessions, what we basically looked at affirmation app. So in the affirmations app, what we did was we understood all the different kinds of resources that are available, how to drag in edit texts into your main Android, the Kotlin layout. So when you're basically debugging or when you're testing your code using an Android emulator that you have installed. So we have seen how to bring in edit text. We have also seen the ID field that is basically tagged with each and every edit texts and so on. So not only that, we also studied about lists. We also studied a lot of other concepts where we again came across something called recycler view, right? So in recycler view, what we did was we again took the example of say the InShots application. So the InShots is basically a news application, and we basically saw how the news is basically changing. We saw different kinds of views. So using different kinds of views, we also saw how the people at InShots are putting news articles in one place. So we saw the heading, we saw then the description of the article. We also saw how the pictures are coming, and we saw the recycle view option too. So what we learned was how the screen is basically recycled once the user is basically dragging to the next news article that we come across. So until now, that was the discussion. And today what we'll do is we'll study a little bit more. So today we'll be actually studying about the navigation components in Kotlin that is available. So what we are going to study is we are going to study something called collections. So what is the use of these collections, and we'll also see some other important concepts that you know in order to move forward. So you will need to know the navigation components, and we'll also basically have an overview of how the entire activity lifecycle of this Android applications work. So that's the agenda for today's session. And towards the end, what we would do is we would also basically build an app using all the concepts that we are studying today. So it's really important that we know the basics of the previous programming languages that we studied until now. For example, arrays in Java. You should just know very simple programming concepts, and you'll be easily able to grasp the concepts that we'll be learning today. So that's an introduction to this session, and that's also a basic introduction to whatever we have studied until now. So using the knowledge of whatever we have studied till yesterday, so we'll be continuing with our session today. So this is the session 3, and I welcome you all to session 3. So let's just get started right away. And so these are some of the things that we almost discuss in every session. So these are some of the things that you need in order to basically run all these Kotlin programs that we are doing in every application. And we are also studying about all these applications in every session. So in order to code that session, so in order for you to become familiarized with Kotlin, you'll need Android Studio as the software. And installing Android Studio is pretty much straightforward. You just need to go to the Android Studio website, where you can just immediately download it for your 64-bit machine. So computers, internet connection, a stable internet connection, Android device, and USB cable. So this is another important requirement. Let us say that due to some reason, um, you aren't able to run the Android emulator in your laptop. Um, generally using Android emulator is a better option, but you can also even have an Android device. Your Android device, you can just connect it to the computer via the USB cable, and also basically debug the if you want to debug or if you want to run your application and see how your application is exactly fitting on the screen using all those views that we studied in the previous sessions, you can do that as well. So uh, these are some of the equipments that you would need in order to run your application. So moving on. Like we discussed in the previous slide, Android Studio is something that is really important if you want to run programs. And coming to Android emulator. So Android emulator is nothing but a virtual device that is basically created in the Android Studio application itself. So when you hit run, an emulator basically pops out. So we have basically seen and run programs using the Android emulator in the first two sessions as well. So just in case if you have an iPhone or not an Android device, if you're not using an Android device, you can as well just install the Android emulator that is being provided here to basically run your applications, troubleshoot your applications, and do various functionalities, perform various functionalities using your Android emulator. So that is one important thing about an Android emulator to know, and you can install it. So these are some of the prerequisites. So even when the session started, I discussed about some of the prerequisites that you need to know: basic math skills, computer literacy, computer and headphones, internet connection, and Android US and USB cable, as we discussed before. So learning objectives of the entire session is you have to build your first Android app. So we have basically run more than one Android apps as such, but at the end of the entire syllabus, when the syllabus of the entire Android study jam is over, so you'd be able to build a lot of Android apps by your own, and you'll also be able to set up Android Studio on your computer by after installing it. And we'll also be learning a lot of Kotlin programming languages in this session. So this session is probably more focused over learning the Kotlin programming language to a much greater depth. So this is what this session would be all about. And yeah, moving on. So this is some slides that I basically show in almost every session. So here I'm basically just showing you the list of syllabus that we cover before we complete the entire syllabus of Android Study Jam. So you would be studying a list of so many topics by the end. And until now, we are currently in Android Study Jam session 3. So we have basically finished the first four objectives, and we have finished until 7 and 8 as well. So today we'll be looking at navigation component a little bit more. So that's about navigation component. We'll be having a basic introduction into navigation components, and basically to until scrollable list was covered in the previous session, and this session what we would do is we'll be understanding an introduction to navigation between the screens. So that is 7 and 8 would be covered today. And 9, 10, 11, and 12 are the syllabus that is planned for the future. So we would be also offering some more sessions on Android study jams where you would be basically looking at advanced navigation examples. We'll be navigating between apps, and we'll be studying coroutines, and we'll also be getting and displaying data from the internet. So once the entire syllabus is over, you would be pretty confident in building Kotlin applications, and you'd understand how to use Android Studio very effectively. And these are the last three topics. So these last three topics also would be covered in the future sessions as well. So we'll start with Android Study Jam session 3 and the concepts that you need to know for today's session. So for today's session, we have collections. So let me introduce you to collections, something called collections. So as the name suggests, you can already have a clear picture of what collection means. So in layman terms, it's nothing but a collection of similar objects. So when we think about collections, you might have, a lot of collections. You might be collecting a lot of items. Say you might be collecting currencies of different types. You might be collecting seashells of different types and sizes, and so on. So Similarly, a collection is basically a group of related items, right? And it could be a list of words or a set of employee records. So when we learn collections, which we would be focusing majorly on today, we'll be basically understanding more about collections. We'll be understanding the theory behind collections. Why do we need collections? And also, not to forget, we'll basically also be doing a hands-on session using this collections concept. So when you're using collections, what are the important things to keep in mind, and how we can map, the concept of collections to the previous concepts that we studied until now. So this is a basic definition of collections. So collections is nothing but a group of related items like list of words or a set of employee records that we studied until now. And the collection can have the items ordered or unordered, and the items can be unique or not. So basically, uh, it's not necessary that the items should be ordered or unordered. They can have items unordered or ordered, and there can be duplicates as well. Can be unique or it could not be even unique. So Kotlin provides numerous functions for adding or deleting items, viewing and manipulating collections. So uh, we also studied in Java. So for example, if you take Java or if you take C++ or any other language, we basically saw different kinds of things, you can do. If you have a list, say, suppose if you take Python, for example, you can see different kinds of functions that are basically attached with the list, or you can try to, have some functions in order to manipulate those collections. So basically the same thing you can do in Kotlin as well. So if you have a collection of similar things, you have some functions which will help you to really add more value to your use case by performing certain functions. So the other advantage here is you basically need not type the code for each of these functions, right? So they are already coming in as a package. You just need to use them. And once you use them, you'd basically be able to retrieve the data that you are expecting from the collection. So that's about some of the functions that are already present with these collections in Kotlin. And a collection usually contains a number of objects. So this number may also be zero of the same type. So again, the third point basically says that it can contain any number of objects, and the second part of the sentence says it should be of the same type. So that is another point that you need to keep in mind. And objects in a collection are called elements or items. So similarly, say if we take an example of array in Java, and you're basically saying you're iterating through all the elements of an array. So uh, when you are iterating through all the elements of an array, basically you want to perform some kind of mathematical operations in that array, or you want to basically use or perform some operation so that it is giving the final user some uh, good application, or let us say it is giving some benefit out of the operations that you're performing. So that's about collections for now. Okay, so I'll just probably summarize it once again. So a collection is nothing but a group of related items. So it could be words or a set of employee records, or basically whatever you can imagine. So basically a collection, or say in layman terms, you can just consider it to be a collection of similar objects. And basically, again, here you can create a list, and we'll also be studying about set, and we'll also be studying about maps in this particular session, what all these three are and how to even basically even distinguish them. And we'll also be studying more about set and lists, and we'll also be doing some hands-on using the same. So that is about collections until now. And now moving on to set. So set is another type of collection in Kotlin. So it's again a set of related items. So you can basically compare sets with some of the mathematical chapters that you probably studied a few years back, where you have a set of things. These sets of things are basically having similar types of objects in them, and then you are performing some kind of set operations where it can be some kind of intersection, or it can be union of sets, etc. So here also the concept is somewhat similar to the sets that we already know, and an item can be in a set or not, but if it is in a set, there is only one copy of it. So this is a very important point to remember. So there can be only one item or one copy, and it can't basically have duplicate values in a particular set. So each set is unique and distinct. So unique and distinct is the keyword that uh, generally we use in order to represent set. And the other thing is we can also define something called a mutable set and an immutable set. So what basically these are is, so when you basically initialize a set and initialize them with some numbers, let us say a set of numbers with the same set, but in the different order, by you can basically make it into a different order as well. So we'll be basically even looking at the hands-on of the same. And so until here, I think the concepts are clear. So this is something called a Kotlin playground. So in Kotlin playground, what happens is you can basically code whatever you want in your Kotlin playground. So it is very similar to basically coding in Kotlin using the Android Studio as well. So in session 2, what we did was we again coded in Kotlin using the Android Studio, and we basically built an affirmations app. So the app would provide you affirmations about, uh, you know, just general daily things. So it would give you some thoughts, and what happens is all these affirmations are basically laid out on a list, and after they are laid out on a list, these affirmations can be displayed using the views. We coded the entire thing in the previous session as well. And here Kotlin Playground is basically an place, or as the name suggests, a playground where it lets you to do some operations in Kotlin. You can basically test some functionalities, you can write some functions, you can write uh, output statements, and you'll also be provided with an output console in order to see what would be your output of the same. So this is about the playground that we would be understanding in today's session. And now coming to the program. So what we have here is basically we have a list. So what we are doing here is we are basically creating a list called numbers here. And this numbers list basically has a lot of elements in them. So we are making sure that this list also has duplicate items of a particular element. So in the previous slides, or just before, sometime we understood what is what structures basically allow duplicate items also to be present in a list, and what structures do not allow duplicate items to be present in a list. So here, when we studied about lists, we also saw that it does also allow some duplicate elements to be there. And in the next line, what we are doing here is we are printing the entire list. So what here exactly happens is you're using the dollar numbers. So you can basically compare this printing of dollar numbers to, say, C programming language, where you would write %d comma and the variable name. So let us assume that you have basically declared a variable name using the integer data type. Once you declare a variable using the integer data type in C programming language, what you would have done is you would have just written on the next line printf, and in double quotes you might have written %d/n, and then you would write a comma, and then you would write the variable name. That's what used to happen in C. So you can almost compare the same thing to Kotlin, where instead of %d and comma the variable name, you are just writing a dollar here, which means that this dollar and the numbers which is there in the round brackets are basically referring to the same list as well. And it would have all the elements of the list and it would print the list as well. So that is something that you need to know. And previously we talked about a list that has items of similar kind. And when is it useful? It is basically useful when you have some functions that are also being added to that list. So when you are performing some functions like sorting, or let us say assembling them in ascending order, or assembling the elements of the list in descending order, it can be of some use, especially when you take some industrial use cases. So uh, in some industrial use case, for example, if you want to basically arrange them in descending order so that another functionality can be performed. So this is the basic use of it. And like we also mentioned, it becomes easy if we are already provided with such kind of functions from before itself. So you do not need to code the function sorting. So again, there are a lot of ways in which sorting method can be coded, but for the simplicity and for easier usage or access of it, they have basically given you a lot of functions where you can basically experiment as we are looking at this. So this is something to keep in mind. And the same thing in the next line, val set of numbers is equal to numbers.toSet. What happens here is you're basically putting all the numbers, all the elements which are present in the numbers list into a set. And just before some time we studied the properties of a set as well. So what did we study in the properties of set? We understood that basically if the elements are present in a set, there shouldn't be any duplicate elements in a set. So that is something we studied about set, and something that we really need to keep in mind for set. And then in order to display that set, we are just saying println, and in the double quotes we are just saying set, and we are basically printing the set. So how to print the set is again just as we discussed before, we are using this dollar symbol like the way we used to use in say C or C++ or Java, where say for C example, if I take, we used to say %d comma that variable name. So the same thing we are doing here as well. And then we are making a few more sets here. We are basically saying set one and set two. And this set one and set two is basically containing this set of methods. So again, these are some already defined functions, already predefined functions where there is already a definition for all this, and you're just invoking that function by just calling that function. So whatever that set of would return, basically the functions would have a return type, like in Java, where if it was an int, it would return an int data type. If it was a string, it would return a string data type, and etc. So similarly, we have something called set of function, and the return type of the set of function would be basically stored in set one val. So again, val is like a data type. So this variable val set one, the return type of set of would be stored. And in set two, the same thing happens. And here we are actually saying it to be a mutable list. So mutable list of 3, 2, and 1. Basically, again, here what you're doing is in the next line, if you see, you are basically saying here in dollar set one double equal to set two. So you are basically comparing the equality of sets. So this is what we mentioned in the previous slides as well. So using the set, you want to do some kind of operation. So this is where if you compare it with mathematics, it's slightly easier to understand what is actually happening and what would be the result of comparison. Generally, the results of comparison is basically a Boolean true or basically a Boolean false. So we have to see as to what is it evaluating to. Once it is evaluating to Boolean true, you can perform an operation, or else you can not perform an operation. So generally for use cases, what you would do is you would put the Boolean true based on if you're getting a Boolean true or based on if you're getting a Boolean false value, you put that in a conditional. And conditional is basically if else statements. And once you put them in a conditional, you can take the program flow in a particular way. So this is about the code that we have written here. And in the last line, we are basically saying, does it contain 7 or not? So this is about the entire code. Again, contains is again a function, and you're basically accessing that contains function using the dot operator. So in Java, again, for example, when you take it into consideration, you can use the dot notation in order to invoke particular function of a particular package. So you just say system dot out dot println. So in that system, again, you're searching for dot and then you're searching for dot println. So I'll give you another example where I'm using the same. So if you see the affirmations project that we did last time, and if we see the data source file dot Kotlin file, here in this data source dot Kotlin file, what we did was in the R, that is resource, uh, resource, we went to string and then we dot affirmation one. So we had basically made so many affirmations in our string.xml file, right? This is what we studied in the last session as well, where we have so many strings and each strings are labeled an unique ID. And after each of these strings are labeled and given a unique ID, we have a unique thought or affirmation for each of them. And once we have a thought for each of them, in order to access them, what we would do is we would basically go to the resources, and from the resources, we would take it. So generally, this is what we have been following until now. And even on the activity main.xml, if you go and if you go to the recycler view, we also studied a lot of attributes here, and one of the most important attributes is the ID field. So if you want to reference this recycler view in order to perform some kind of operation, you would basically take the recycler view ID. Or again, for example, in the first session when we did a simple calculator, we from the resources, we basically took the IDs of each of the edit text fields. So that's about dot notation. So when I run this app, you would be basically seeing each of the values here. So the last one is evaluated to Boolean false. Here 1, 2, 3, and 3 to 1. Basically, it's seeing for the number of elements if it is true or wrong. And set, as I told you, each element of the set is containing unique values here. Sorted is another method that is being again invoked by the dot functionality, just like in Java, where again all the elements of the list are being sorted and then arranged. And this is about the code that we have studied until now. So until now, we um, saw what this program does. I hope the program is clear for everybody till now. So we saw what is sets as well. Now we'll basically be moving on to something called a map, and we'll understand what is a map. So the last type of collections that you learn is about what a map is or a dictionary. So a map is nothing but a set of key value pairs designed to make it easy to look up a value given a particular key. So yes, so this concept again can be compared with one of the concepts that we studied about in the JavaScript session, where uh, we talked a little bit about JSON files. So in JSON files also, what we have is we have something called key value pair. So uh, the value, the name key value pairs are basically appearing in many places. Keys are unique and each key maps to exactly one value, but the values can have duplicates. So again, this is another point that is probably common. We are kind of looking at how unique and duplicate things work here in Kotlin, and what kind of structures are supporting duplicate elements in them, what kind of structures aren't supporting duplicate elements in them. We are looking at all of this in this session as well. So this is about the second point. And values in a map can be strings, numbers, objects, or even any other collection like a list or a set. So here, when you take maps into consideration, it's kind of giving you the entire flexibility. So it is much more flexible than set. So the aim of this session is basically we are comparing set, list, and other structures here. And we are basically looking at which one is more flexible among them. We are studying each of their properties as well. And after studying each of their properties, we are coming to a conclusion as to what can be used in your application. So we studied about how the referencing happens. So now I'll be just giving you some more information about maps and navigation components here. Especially when you're taking maps, it is very useful when you have pairs of data, that is, and you can identify each pair based on its key. So I'll be having a diagram also to explain you what maps is in a much greater detail in the next slide. But for now, you can just imagine that you can replace the code, and you can also make something called a mutable map. You can create a mutable map in order to store, say, if you wanted to store, probably for example, names of students and the marks that is obtained by each of the students. So these are some pair values that you would like to store in your program. You can easily do that using maps. And in my situation, so if I'm thinking that I wanted to basically store uh, the people, the names of people and height of them, or the names of people or the weight of the people, so as to perform some kind of operations in the future using them. So I would like to have the average and then probably process for a use case application where I would take the average height of each of them, and it could be of some use. So that's about maps. So it is particularly useful when you have pairs of data and you're dealing with pairs of data. Again, like I told, so when you're making a mutable map, it's like arguments. So the data types of these arguments are also basically specified then and there itself, like string and integer. So we'll be looking at that as well in our hands-on session. We'll be looking at a code which would perform the same. Now, let me just move to the next slide in order to exactly show how maps work. So on the left hand side, you have flowers, animals, and trees. And on the right hand side, you have daisy, sunflower, rose, and different kinds of animals. So probably in Java, you can map this concept to a class, right? Where you have class animals. And once you have class animals, in that particular class of animals, you have very similar animals present in that particular class. So that is one classic example to understand what exactly object-oriented programming means in Java. So that is a very good example of comparing maps to some application or some program in Java, which is basically present in Kotlin. So you have this flowers, and inside flowers you have different kinds of flowers that basically are grouped together under the class flowers, here under the map flowers. So that is about maps. And this is the code that we'd be studying about in order to understand maps here. So like I told you, I'll be having, and I wanted to basically gauge the names of people, and I wanted to have the age that is related to each of them. And like we discussed in the previous slide, it is better that we always have pairs of data in order to perform mapping operations well. So if you wanted to perform map operations well, so it is always better that you have pairs of data. Here the pair is string and an integer, and like you can see, string and integers are mentioned like how we mentioned parameters in Java. So that's the reason I had included in the first few slides that you had to know a little bit of programming in order to understand Kotlin to a much deeper level. So in the sessions as we are going forward, here we have two names here, Fred and Anne, and basically their ages are 31 and 23. Again, here what we are doing is just like how we used to do in Java. We have, when we create a class of animals or an animals class, what we would do in the main class is, in the main class, we would basically instantiate an object of that animals class. And if you wanted to perform some kind of operations on the animals class, that could be performed. Or let us say that you want to basically access some function of the animals class, you can do that as well. Similarly, you can map that concept of creating objects and calling functions or methods in Java to Kotlin here, where you're basically having this people's ages to be the class or the map here, and you have key value pairs inside. And once you have the key value pairs inside, you are basically accessing some map functions like put, etc., using this dot notations. I hope it's clear until here. Uh, so I'll give you a recap slash summary of what we discussed about maps until now. So like I mentioned in the initial slides, that it is always better to have some fundamentals of coding in Java, for example, and you're using maps when you want to basically introduce two, that is pairs. So if you have pairs of data with you, it is always better to use maps. And here I wanted to use maps in order to store the names of people, say Fred and Anne, and I wanted to have the age of them as well. So how are we storing them? How are we storing this data is by the concept called key value pairs. So you have a key and you have a value to that key as well. And again, key value pairs are something you'd come across when you're studying JavaScript. So in the previous sessions, in the JavaScript session, we studied about what key value pairs are in order for you to get more clarity about key value pairs. And this is probably a mixture of that concept and the object-oriented class concept in Java, for example. And once the class is being created, the values that are being inserted to the class are being put here. And once this entire thing is written, you can basically have objects, and those objects can be made or instantiated, and using those objects you can basically call some functions inside the class. And some functions here are put, or you know, you can have many other functions as well. So there are a list of functions that you can understand when you Google for the number of functions, but here I'm just including one. So let's see what happens here. And for each is again one kind of loop. So we have seen for each loops in the previous sessions as well, where we discussed about how the looping happens. So each and every element of that particular people ages map is basically gone through, and once all the objects or all the data inside it is complete, once the program flow goes through each and every data that is present inside the map, the entire map is basically printed. That's what is happening in the last line of code here. So as we can see, what exactly happened is, in the map, Joe was basically inserted with age 51, Barbara was inserted into the map with age 42, Anne was inserted into the map with 23 and Fred 31. So Fred and Ann were already previous data that were already existing. And you can also basically introduce more data into the map by the put function here that we see. And also you can also introduce them using the square brackets as well. And once you print it, the entire map is being printed here. And now using the for each, you're going through each and every element of that map. So I hope uh, the entire program is really clear. Now we'll be studying about something called the activity life cycle, right? And activity life cycle is nothing but the routines or a set of procedures that are followed when you basically open any app, right? The first point says, as the user navigates through, out and back to the app, the activity instances in your app transitions to through a different states in their cycle. What it means is, let us say again, take the example of InShots application that we studied until now. So in InShots application that we studied until now, we are basically using a scrollable list in that, where we are displaying each and every news article, and that scrollable list is basically the entire coordinator for the entire application. So that that recycle view is basically being recycled again and again, and that view is basically binding everything together. So that is about that application, and we can see a lot of stages as well. So in the next slide, we'll be showing you a diagram of what are the different stages in which an application has to go through, or the life cycle that a particular application follows. So we as developers, we being developers, it's really important that we kind of study the different states or uh, the life cycle that it goes through. So you can basically imagine this to be uh, similar to water cycle. So when the water is in the sea, it's in the form of liquid, and as the water evaporates, it becomes water vapor, and once it reaches the cloud, it again condenses. So these are the various life cycle transitions or the state transitions that water goes through. And similarly is the case with a lot of applications as well. So it goes through many life cycle methods, and we'll be looking at these life cycle changes or transitions using a diagram, and also on the Android Studio application as well, hands-on. Talking about life cycle and life cycle activities, an activity is basically referred to one screen in an application. So it can be one news article that is being displayed in front of you, or it can be any other user interface that the application is basically displaying. So that is what basically an activity is all about. And it is very similar to a single window. So this is another point that I would like to add. So there is single window application in many desktop applications as well. Now, within the lifecycle callback methods, you can declare how your activity behaves when a user leaves and re-enters the activity. So for example, again, if you take consideration of InShots applications, so InShots and Times of India are the applications that we have been taking from the session one and studying its various characteristics of how it behaves, because it is already a fully developed and published app on the Play Store. So if you're building a streaming video player, you might pause the video and terminate the network connection when the user switches to another app. So this is also, again, really understandable. And let us say that you are basically listening to a song, or you are basically listening to, say, a YouTube video, and watching a YouTube video, and suddenly you get a call. And now what happens is, the developers who are basically responsible for building your application would have coded or would have developed the application in such a way that if a task with a higher priority comes, and what happens is the application or the scheduler should be able to schedule that first based on the priority, and once the high priority task, that is attending the call, is done, you can basically resume viewing your YouTube video, right? So that basically happens. That is what is being explained in point 2. These can be buttons, lists, and edit texts. So these are all the elements, and we studied a lot about buttons, lists, and edit text in session 1 and session 2. The activity, however, has its own life cycle, and you can listen to the events emitted by the activity through life cycle methods. So we'll be looking at what these life cycle methods are in some time. So that is about the activity life cycle methods, and life cycle methods can be of, again, various types that we'll be listening here, that we'll be seeing here. So as you can see on the screen, we have a map, or we have a diagram, and this diagram basically says the different kinds of activity that our Android application goes through. So there is on create method, there is on start method, there is on resume method, and then there is activity running. You can see on pause, on stop, on destroy, and from on stop you can see one more arrow that is basically redirecting you to on restart method. And towards the left hand side you can see another arrow that is basically saying the app process is killed, and it goes back to the on create method. So we'll be basically discussing about the entire activity cycle right now. On create is basically the activity when it is first created, or let us say that immediately when you open a particular application on your mobile phone. So on create is the method that is basically created at the starting. This is where all the static work is done, like creating views, building data into lists, etc. We just build data lists in this tab, where in this place we are basically making data. I mean, we are basically binding the data to lists, and we are binding a lot of data to, say, a map, etc. So that basically happens in the on create method. And the next one is on start method. So what is on start method? If you take into consideration, on start is invoked when an activity is visible to the user. So basically what happens here is the binding has been started, once the binding has been started, you can use this on start method so as to make that particular piece of code, or let us say that particular activity, we just talked about what activity is, a single screen, to be visible to the user. So that is about on start. And on restart, so it is not necessary that each and every one of the thing you are able to basically see while making of the app. And on restart, just to tell it in one line, is invoked after the activity has been stopped or prior to the starting page. So that is on restart. So once you close the application, again taking InShot's application into consideration, once you close the application, on restart is invoked. So once you stop it, and let us say some higher priority stuff, higher priority task is coming, that is when this method is invoked on restart. On resume is invoked when the activity starts interacting with the user. So this is another activity. So once that higher priority task is finished and you wanted to basically resume with whatever you were doing previously, as the name suggests, you can use the on resume method. And on pause is basically invoked when the activity is going into the background has not yet been killed. So again, taking this InShots application into consideration, when you're basically browsing through different news articles, and let us say a higher priority task comes in between, which is a call, and you attend to the call. And when you're attending to the call, what happens to the already present InShots application that basically goes to the background application. So once it goes to the background, it will be basically in the background, but it's not killed. So that is what is the use of that function. And onStop is basically invoked when the activity is not visible to the user. So once the activity is not visible, it goes to something called onStop. And from onStop, again, if once it's stopped, you can either restart it and it goes through that branch, or if the app process is killed. Suppose if a higher priority task comes in, the app process is killed, and then again it redirects itself to the onCreate method. And onDestroy is the final call received before the activity is completely destroyed. So let us assume that the functionality of that particular Android application is finished. And once the functionality of that particular Android application is finished, it goes to onDestroy method, where that particular activity is destroyed as well. So that is the entire summary of this Android lifecycle diagram. And that marks the end of this session.